Welcome to my channel. So here in today's class I'm going to discuss about delay line canceller. So how we use delay line canceller, why do we use delay line canceller, and what are the basics of delay line canceller, and what is the block diagram, and what is the working procedure of this delay line canceller. All those things here I'm going to discuss in detail. So here I'm going to will be explain delay line canceller. So how can use delay line canceller in radar system, and why do we can use delay line canceller in radar system? Okay, how we can use delay line canceller in radar system, why we can use the delay line canceller in radar system, what is the purpose of the delay line canceller in radar system. Okay, so here these are the contents I'm going to discuss in detail. Okay, the first thing is it is introduction. What is the delay line canceller and what are the types of the delay line canceller, how it is going to work. Okay, and basics of the delay line canceller, where it can be used, how it can perform, what is the necessity of the delay line canceller, and coming to block diagram. So what are the modules in the delay line canceller, how they perform to get the required response to detect the target in the presence of space, and working of delay line canceller, how it is going to work based on some procedures, and there are some derivation part is also available. Okay, all those things here I'm going to discuss in detail. Coming to the introduction here. Okay, coming to the introduction, the delay line canceller is one method. Okay, the delay line canceller is one method commonly employed to extract Doppler information. It is suitable form for displaying on PPI scope. Okay, to extract Doppler information means till now we detect the target in the space, that is regarding to only fixed target, whereas we want to detect the as moving whereas we want to detect the moving target in the space. In that case, we need there is a one concept, that concept nothing but Doppler concept. So by using this Doppler concept, we can easily extract the target, or we can easily detect the object in the space. Okay, and here the delay line canceller is attached, it is a filter. And why we can use delay line canceller in radar system, because of to eliminate the DC component. The DC components are nothing but unwanted signals or clutters. Okay, those are eliminated from the eliminated here, and such signals are from the fixed target and pass the AC component of the moving target. Okay, and here there are two types of delay line canceller here. First one is time domain filter or time domain delay line canceller, or frequency domain filter or frequency domain delay line canceller here. So these are the this is the basic introduction information about the delay line canceller, right? Here the delay line canceller is can be used to eliminate the DC component of clutters, that is regard to the fixed target signals, and pass the AC component signals, such as regarding from the moving target indication, right? So coming to the basic delay line canceller, here is the first content here. So here it is used, that is nothing but the delay line canceller. It is used in MTI radar system. Okay, and here it can be work as a filter, which where it is low frequencies occur, that such a type of low frequency signals are removed by using this delay line canceller here, and it can be utilized as the filters to remove the low frequency signal. It can be utilizes the it can utilize the filters to remove the low frequency signal, low frequency components. That low frequency components are from the fixed target. Next, and here it eliminates the low frequency clutters in received signal at radar system. So that clutter means unwanted signal. That unwanted signals are reflected from the fixed target. Okay. So because of delay line canceller here, it improves the resolution of object identification. It improves the because of delay line canceller, it improves the resolution of resolution for the identification of the target here, or nothing but it is object. So usually we have an MTI radar system in that we connect the delay line canceller just before of display. Okay, and by having this we have the improved resolution. This is the basic information of the delay line canceller. So coming to the block diagram here, let us see this is a receiver module and delay line module, subtractor circuit and full wave rectifier circuit. That full wave rectifier circuit is the absolute response of the circuit here. Okay. So here we have the first point here. Let us see here. Here we have a received signal of radar, and here we provide a delay line canceller, which is delayed by a PRF, pulse repetition frequency, that is T equal to 1 by pulse repetition frequency. That is amount of delay here. So here this is the receiver. So the received signals are received at the radar receive station, and that signal is applied to the delay line. That is the amount of delay, nothing but T equal to 1 by PR of amount of delay. After that, we can subtract these two signals here by using subtractor module, and then finally we are getting the response, absolute response, that is V. That V. Depending upon this V, you can easily display the perfect object that it is a as well as it is a moving target in the space. Okay, and here I have a signal here, that is V1 is a received signal here. I have a signal here. Thus this signal is applied to the delay line canceller, and another way here we can apply this one. So this signal is subtract with the delay line canceller signal, which is to ultimate which is we have a ultimate resultant signal, which is elimination of clutter, low frequency components, right? So here let us see here the detailed derivation process of this particular block diagram of delay line canceller. Okay, so here I have a signal that is v1 equal to k sine 2 pi fdt minus phi naught. Okay, where fd is pulse repetition frequency. This is the original signal here, and the delayed signal is V2. That is V2 equal to K sine 2 pi FD. T minus TP amount of time delay is occurring here, that into minus phi naught. So the output is V. So the output response from the subtraction is V equal to V1 minus V2. So substitute these values in this equation. So we get this response as this one. But we know sine A minus sine B from the trigonometric formation. We can know here this is sine A minus sine, that equal to 2 sine term and cosine terms. Okay, so based on this concept, we can derive this above equation V equal to k of 2 cos 2 pi fdt minus phi naught plus 2 pi fd of t minus tp minus phi naught by 2 into sine 2 pi fdt minus phi naught minus 2 pi fd of t minus tp minus phi by 2. By simplifying this equation, finally we get this equation. Okay, V equal to k into 2 sine pi pi fd tp cos 2 pi fd of t minus tp by 2 minus phi. Okay, so here the output delay line canceller contains a sine term, cosine term at frequency fd with an amplitude of this one. So here from this This is the response. This is the response of our system. This is the response of our system. It is represented in amplitude. It is represented in amplitude. And this is nothing but frequency domain of our signal here. Okay. This is the response of our system. 2 2k in 2k into sine of f pi sine of pi fdtp. This is the actual response of our system. It can be represented as in amplitude, right? And here the frequency response function of the delay line cancellor h of f is, that is h of fd, that equal to 2k sine pi fdtp. This is our actual response. But coming to the here, h of fd equal amplitude of output response by amplitude of input video signal. Okay. And here what we have, the resultant signal, that is removed the clutter, that is ground clutters. What we have, the received signal. After processing the received signal, we have to get the resultant signal, that is the response of the system. So that response, how the unwanted signals are removed, let us see this graphical representation here. Okay. So here we see how the ground clutter signals are removed. Now we can plot the respective frequency signals below based on this signal. Based on this response, we can draw the respective plots of the following graph here. Okay. And let us see here. So this is the on x-axis we can take it as a frequency response. So f equal to 1 by t. That in that, but I think, but it is a fd or fp. So this is nothing but 2 fp, like that. This is 3 fp, right? And here the amplitude is 2 times. 2 times is here. The amplitude taken at an y-axis. Okay. Let us see here. Let us this point here. This is the amplitude is 0, means the response of the system is 0. So nothing but, so due to the ground signal, regarding to the ground signal, we are not getting the response at the, we are not getting the any output response at the output side. That's why here the amplitude is 0. So such a signal we can eliminate here. Eliminate. Okay. Eliminate here. So here we see the elimination of low frequency noise. Low frequency, this is the low frequency signal, and this is also another low frequency signal. These are the different low frequency signal. Okay. Right. So these signals are regarding to the ground signals. So at that particular situation, the output response is 0. The frequency of the signal at the output response in terms of amplitude is 0. Right. But ideally it is 0 response, but practically there is a slight signal will be available at the output system. Okay, this is the basic information about the delay line canceller. What is meant by delay line canceller? What are the types of delay line canceller? And what is the basic content of the delay line canceller? How it is going to work? Why it is used? And what is the block diagram? What are the modules are needed to get the actual response to get the moving target in the space? How it is going to working based on the procedure? We get the actual response. That based on that actual response, how it is eliminating the unwanted component, that is regarding the low frequency signals from the ground, regard to the land signals. All those things we are discussed in this concept. Thank you. Thank you.